Hello, so I've just finished making another question generator that you can see on the screen. It's all about using the nth term in sequences, so it's another video on algebra. I have written, just the same as I have in a couple of my previous videos, a few areas that you need to be comfortable with. These are just areas that I've kind of thought about that are required to be able to access some of this work. So if you are unsure about substitution, operations with negative numbers, using the nth term rule to find a term in a sequence, or with adding or subtracting decimals, this video maybe isn't quite right for you just yet. You need to go away and have a look at those topics. So the question generator that I've made, I'll go through that again at the end, but it's fully what we call differentiated, so there are levels of different difficulties that you can have a look at. Okay, I'm going to go through 4 examples of increasing difficulty. So you'll be given a sequence like this one, and you will be asked to find the nth term of that sequence. That is that the first term here is n. So when n is 1, this term in the sequence is 23. The second term is 35. The third term is 47, and so on. And this sequence will go on and on and on. Now for these questions, the first thing you are going to need to do is to find the difference from one term to the next. So in each of these, how do I get from 23 to 35, from 35 to 47? I want you to include the sign that goes with before that as well. So this one, don't just write 12, I want you to write plus 12. And it's the same for each of these. Each time we are adding 12 to get to the next term in the sequence. Now this tells me that it is related, this sequence is related to the 12 times table. Now the way we write that in maths is to write 12n. All that means is your 12 times table. So underneath the n, down here somewhere, I'm going to write 12n. And then I'm just going to list out the numbers in my 12 times table. When I do this, it's really important that you, underneath the 1 and the 23, you kind of line everything up. So I'm going to write 12 here. Underneath the 2 and the 35 down here, I'm going to write the next number in my 24 times table, and so on. So make sure that you are lining them up. Okay, as soon as you have done that, we want to get back to this sequence, this 23, 35, 47. So starting with my 12 times table, I'll do this in a different colour. I want to say, how do I get from 12 to 24, from 24 to 35, and so on. Each time, in this case, you are going to be adding 11. So my nth term rule is simply this 12n plus 11, because then you could always just try it. If I was trying to find my 5th term, n would be 5. So when n is 5, 12 times 5 gives me 60. 60 plus 11 gives me 71. And that kind of matches up with what we've already got. Okay, so that's your answer, 12n plus 11. Let's do one now that involves some negative numbers. Now watch out for these. This is where students tend to go wrong. You're going to start exactly the same way. This is n is 1, 2, 3, 4, 5, and so on. Okay, now watch out for those negative numbers like I said, because here's 0. To get from negative 26 to negative 31, you are actually getting further away from 0. So you are taking away 5. A lot of people just see the 26 and the 31 and they think, oh, we'll just add 5. But if you do that, you're kind of ignoring the negatives. So because each time here, I'm subtracting 5, that's my what we call term-to-term rule. How do I get from one number in the sequence to the next? I'm going to write out negative 5n. Remember I said it's really important that you include the sign that goes before it. So your negative 5n simply means, we've done that. Negative 5n simply means you are taking it's your negative 5 times table. So I'm just going to write out negative 5, negative 10, negative 15, negative 20, negative 25. Once you've done that, you know your sequence is going to start with negative 5n. Then I say, just the same as I did before, how do I get from this number to this number, from negative 5 to negative 26, and the same all the way along here. So to get from negative 5 to negative 26, you can use a number line again. Here's 0, here's negative 5, negative 26 is down here somewhere. So I'm actually taking away 21. So it becomes negative, should have written negative 21 there, negative 21, negative 21. So my sequence then just becomes negative 5n and then that negative 21. That there is your answer. Okay, that's question 2. 2 more examples. You need to watch out for decimals. A sequence could involve decimals or it could involve fractions, and also negative decimals and fractions. So you need to be very careful here. Again, you're going to start this question exactly the same as you did before. So you just simply going along here. And then you're saying, oh, so that was 1, and it's 2, and it's 3, and it's 4, and it's 5. So to get from negative 2.7 to 2.8, again, number lines are really useful with this. Start by writing 0, negative 2.7, and 2.8. I want to figure out how I've got from this number, negative 2.7 to 2.8. So if you think about it, to get back to 0, you've added 2.7. And then to get from 0 to 2.8, you will have added 2.8. So in this case, in total, if I add 2.7 and 2.8, it's going up in 5.5s. You could also just check it with 2 positive numbers to avoid doing how do you get from this negative to this positive. So for example, you could say how do I get from 8.3 to 13.8, and that's adding 5. Okay, so because it's going up in 5.5s, all we're going to do is I'm going to write out my 5.5 times table. Again, we write that as 5.5n. So that simply becomes 5.5 followed by 11 followed by 16.5 and then 16.5 add 5.5 is going to be 22, and then you're going to have 27.5. Okay, so then we've done the first step and we know our sequence is going to start with 5.5n. As soon as you've done that, you're going to say just the same as you did before. How do you get from 5.5 to 2.7? So a number line would be useful again. Here's 0, here's 5.5, and here's negative, I should have said negative 2.7, negative 2.7. So to get back to 0 from 5.5, you are taking away 5.5, and then you're taking away another 2.7. So in total, you have taken away 8.2. So my final answer simply becomes 5.5n take away 8.2. And that's it. That's your final answer for that one. Okay, last question I'd like to go through, last difficulty level. This one's slightly different. You are told that the second term is 21 and the fifth term is 42. So if you think about it like this, n here is 1, 2, 3, 4, 5. That is just the number of the term in the sequence. we are told a couple of things here. We are told that the second term is 21. So I'm going to write 21 in the second box there, the second line. The fifth term is 42. So that's all the way up here. Now, as you spotted in the previous examples, with these what we call linear sequences, the difference each time is the same. So in the first one we did, we were adding 12 each time. Second one we'd taken away 5, and the third one we were adding 5.5. So we know that to get from this one to this one, 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 I'm not actually talking about the 1 to the 2, the 2 to 3, I'm talking about these numbers here. We know that all these differences are going to be exactly the same. So we're going to use the two numbers that we've been given. To get from 21 to this one, we're adding the same thing, then we're adding the same thing again, then we're adding the same thing again. So the difference between 21 and 42 represents 1, 2, 3 jumps. So if I did 42 take away 21, I get 21. That 21 represents 3 jumps. So to find out what one of the jumps is, I'm just going to divide this by 3. That tells me that each time to get from one term to the next, I will be adding 7, and this will be the same each time. So now all I'm going to do is I'm going to write out my 7 times table. Again, making sure I line them up. 7, 14, 21, 28, and 35. Okay, final step. I need to figure out how do I get from these numbers to these numbers. And remember, again, this is going to be the same the whole way along. So you're going to use one of the two kind of pairs of numbers you've got. You've got this 14 and 21. You've got this 35 and 42. So each time here we're actually adding 7. So my sequence is just this 7n, add 7. And that's it, that's that one done. Okay, so what I will do, let's go back to the question generator. This one here generates loads of questions, and your answers, you can get them one at a time, or you can show them all at once. And it's, if you just want to practice increasing difficulty level questions like I've just gone through, you can use this increasing difficulty box. If you just want to practice all of the first example, you can just do lots of type 1 questions. If you want to do, I don't know, any of the 4 of the third type of questions, just click that type 3, and so on and so forth. If you've got the hang of all of them together and you don't want to be told which level of difficulty the question is, you can select mix of questions and it will just give you a mixture of them, and then you need to use everything you know to try and figure out which is which. Like I say, I'll put a link to that video in the description, so you can get access to that file as well. Hope that's been useful. That was finding the nth term. I will probably do another video on nth term, but quadratic nth term rather than linear, which is what we've just done. Thanks for watching. Bye bye.